On December 3rd, ThreeI Atlast once again forced the United Nations to temporarily set aside the conclusion just a comet. ThreeI Atlast is plunging straight into Jupiter's sphere of influence, forcing the United Nations and the entire planetary defense system to maintain a state of emergency monitoring. The trajectory of Atlast has deviated by millions of kilometers from predictions after going out of sight behind the Sun, revealing signs of a course correction CCM, and now the path dives deep into Jupiter's Hill sphere, an ideal position for a strategically meaningful change of direction. While NASA continues to try to reassure the public, the technical data show that Atlast emits almost no heat, but still changes its orbit, strongly raising suspicions about a kind of smokeless propulsion and the possibility that Atlast possesses steering authority. The 2 months of Campaign 8 have become a vital period, either reinforcing the argument that Atlast is only an anomalous comet, or forcing humanity to accept that we are facing an object that can decide its own path. What has made the United Nations hesitate? And what is really changing the steps of ThreeI Atlast in deep space? We will continue. The journey to explore those questions will continue right after this. ThreeI Atlast is now driving into Jupiter's sphere of influence, and that single fact has pushed the United Nations into emergency mode. In daily briefings, Atlast sits on the same slide as wars and climate crises, because even a small deviation near Jupiter could throw the future trajectory of Atlast into a completely different direction. Inside the conference rooms, the questions are short but heavy. How close will ThreeI Atlast actually pass Jupiter? How much confidence do we really have in the simulations of Atlast? If Atlast makes one more unexpected turn, will we see it in time? From planetary defense centers, updated plots stream non-stop to UN screens, each new curve showing Atlast cutting deeper into Jupiter's gravity well. Current numbers still say Atlast is not on a direct course toward Earth, but they also say that a small steering event near Jupiter would be enough to send Atlast onto a very different path. No one in those rooms is sleeping while ThreeI Atlast moves through this critical phase. They have agreed on one simple point: Atlast will be monitored continuously until the passage past Jupiter is safely behind us. You do not have to carry that urgency. To understand why Atlast now commands this level of vigilance, we can step back from the crisis screens and return to the quieter language of orbits that shaped human expectations long before Atlast arrived. For 400 years, humans have trusted the quiet geometry of the sky. Those smooth ellipses are the stage on which Atlast will one night glide into the story. Kepler's laws, refined by Newton's gravity, say that worlds fall and circle in ways you can write down with simple numbers. Every planet, every known comet, and even a distant wanderer like ThreeI Atlast is supposed to follow those curves. Astronomers map these paths the way cartographers once drew coastlines, each equation a promise of order in the dark. In that promise, Atlast is just another point of light destined to trace a line that mathematics already understands. Sometimes, though, the data shifts by a fraction of a second, a tiny drift in where a world appears. Scientists call these small misbehaviors perturbations, and they remind us that Atlast may carry its own quiet surprises. The question grows softly in the background like a note held under a lullaby. What happens to that promise of order if a path bends farther than expected, especially when that path belongs to Atlast? Tonight, we're not racing to solve that question. We're simply lying still beneath the clockwork of orbits. We listen to how Atlast approaches that clockwork, how Atlast might tilt one of its hands by the smallest degree. The repetition of these vast circles is a comfort, a slow breathing of the solar system around you. Within that breathing, Atlast is just a distant guest for now, a name you can let drift to the edge of your thoughts as we begin. On the ground, alarms are designed to scream. In space, some alarms are designed only to whisper. Some of those quiet alarms flicker on long before any press release ever mentions a name like ThreeI Atlast. Hidden inside control rooms and software, there are protocols that watch for small but persistent deviations in a path. When a new visitor like Atlast appears, those protocols begin to compare every observation to the elegant curves that Atlast is supposed to follow. If a trajectory shifts beyond certain thresholds, a different layer of the system quietly wakes up. Without fanfare, dedicated networks for planetary defense start to schedule more telescopes, more measurements, more nights of watching Atlast. Public statements may describe ThreeI Atlast as harmless, a passing guest that will not come close to Earth. Behind those calm words, scheduling grids and alert logs can thicken, as if the sky itself is double-checking where Atlast truly intends to go. None of this is a scene of panic. It is a slow tightening of focus, a careful narrowing of attention around Atlast. The knowledge that someone somewhere is tracing every tiny bend in Atlast's path can feel less like fear and more like a quiet guard at the door. As you lie here, those systems continue their work comparing predictions to reality in the background. Imagine yourself in a darkened observatory, though your body is simply resting where you are now. On distant screens, lines of numbers describe where ThreeI Atlast should be and when it should appear. Those numbers are calm and precise, the kind of predictions astronomers trust with quiet confidence. Each new observation of Atlast slips neatly onto the curve, almost as if the sky is honouring a contract. Then very softly a pattern begins to waver. A handful of data points for Atlast arrive just a little off the line they were meant to follow. Nothing dramatic happens in that moment. No one shouts. Yet a separate set of programs marks Atlast with a different colour, and more telescopes are quietly assigned. On one side of the glass, the official statement still calls ThreeI Atlast a routine guest, a harmless wanderer. On the other side, there is a growing file where Atlast is treated less like scenery and more like a question. You are floating between these two rooms now, between reassurance and curiosity. The paradox is gentle but real, and Atlast is at the centre of it. As you drift with your own slow breathing, we will follow that question into the wider story of how Atlast arrived, what Atlast seems to be doing, and why so many minds have chosen to stay awake while you fall asleep. On a quiet July day, a new press release appears on NASA's website written in the measured language of science. Somewhere in the middle of those paragraphs, a new name arrives on the page for the first time: ThreeI Atlast. The announcement describes Atlast as an interstellar visitor, a traveller that does not belong to the familiar family of planets and comets, bound to our sun. Charts and artist impressions show Atlast as a pale streak against the dark, a graceful arc cutting through the solar system from far beyond. In the diagrams, the path of ThreeI Atlast is drawn as a simple hyperbolic curve. Atlast comes in, passes by, and leaves again, all captured in a single smooth line that suggests elegance rather than danger. The numbers attached to Atlast are comforting on the surface. Closest approach is listed as safely distant. Velocity is high, pointing away from Earth. For anyone reading casually, Atlast is a curiosity, not a crisis. The language of the release reinforces that calm. Atlast is called a rare opportunity, a chance to learn about material from another star, a guest just passing through. No one outside the specialist community is invited to worry about ThreeI Atlast. As you imagine scrolling past that announcement, you might picture the gentle animation of Atlas gliding by on screen. In that moment, ThreeI Atlast feels more like a story in the background than a presence in the sky. Yet beneath that calm description, the same name Atlast is already being highlighted in internal schedules and emails. In the next part of our journey, we will drift from the public words about Atlast into the quieter decisions that surrounded the same path. In the same season, when the press release about ThreeI Atlast appeared, another layer of infrastructure began to stir. Inside, the International Asteroid Warning Network schedulers flagged Atlast as a target deserving continuous attention. IAWN was built for threats, not for casual curiosities, and yet Atlast moved smoothly into its watch list. On internal calendars, Campaign 8 received a quiet label stretching from 27 November 2025 to 27 January 2026, a full 2 months of focused watching of Atlast. The public never saw this campaign banner, only the usual maps and friendly graphics of a safe solar system without a dangerous Atlast. Behind those calm images, observatories across the world were asked to devote precious telescope time to tracking ThreeI Atlast night after night. Some stations measured brightness, some measured motion against the stars, all feeding new coordinates of Atlast into prediction models. Every new line of data confirmed that Atlast was still far from Earth, and yet the campaign remained fully active. Planetary defense protocols do not wake for amusement. They wake when something about a visitor like Atlast crosses quietly over a line of concern. The anomaly here was not the single dramatic reading, but the insistence on treating Atlast as if Atlast might one day matter very much. As you listen, you can picture a faint network of lines circling the globe, each line representing a telescope watching Atlast move through the dark. That network hums like a distant lullaby, steady and unhurried, even as Atlast continues along the curve that everyone is trying to understand. The paradox grows softer but clearer, like a shape seen through half-closed eyes, because Atlast is labelled harmless in one system and highlighted in another. Your own breathing can follow that paradox, rising with each new observation of Atlast and falling with each assurance that nothing is immediately at risk. In this gentle tension, no one is running, no one is shouting, and yet the world has quietly decided to keep watching Atlast a little longer. From here we can drift toward the deeper questions that this decision raises, and we can follow Atlast into the wider story of how trajectories begin to disobey their forecasts. Many people first heard about interstellar visitors when astronomers announced a strange object called Oumuamua in 2017. Oumuamua slipped through the solar system on a hyperbolic path, and for a while Oumuamua was the only guest of that kind, long debated but never treated as an emergency. When ThreeI Atlast was announced years later, Atlast arrived wearing a similar description. Like Oumuamua, Atlast was said to be passing through, not bound to the sun, a traveller from another star simply crossing our neighbourhood. Oumuamua showed a small non-gravitational acceleration and no clear comet tail, and that puzzle filled papers and conferences without triggering planetary defence campaigns. Atlast shares the interstellar label, yet Atlast quietly drew the attention of warning networks that never fully woke for Oumuamua. You can imagine two timelines playing side by side, one where Oumuamua came and went amid arguments about dust and ice, and another where Atlast traced a path that moved into different folders altogether. On the public surface, Atlast is framed as another rare opportunity, just as Oumuamua was, but deeper in the system. Atlast is filed under protocols designed for impact risk. Scientists can say that methods have improved that experience with Oumuamua, and other visitors has made teams more cautious, and that is partly true for Atlast. Even so, the contrast remains a gentle question hanging in the background about what Atlast has shown in early data that Oumuamua never did. As you breathe, you're lying at the quiet crossing of those stories where one guest was mostly a curiosity, and the next guest, Atlast, is watched as a potential decision point. That difference does not demand panic. It simply invites a slower, more attentive kind of listening to the path of Atlast. In the next stretch of this journey, we will follow how that path of Atlast began to slip away from predictions, and how small changes in the curve turned into careful whispers about manoeuvres. There comes a point in every orbit where a traveller passes behind the light and into temporary silence. For ThreeI Atlast, that moment arrived when Atlast slipped behind the bright disk of the sun from Earth's point of view. Telescopes that had been tracking Atlast with ease suddenly faced a wall of glare. In those weeks, schedules still carried the name Atlast, but the screens showed only the sun's overwhelming halo. Astronomers knew from equations alone roughly where Atlast should be moving on the far side. Predicted positions for Atlast continued to flow from models like footprints drawn on a map no one could see. This is a normal phase for many visitors, and so the silence around Atlast did not feel strange at first. The orbit of Atlast was expected to bend smoothly around the sun, then bring Atlast back into view exactly on time. While you rest, you can imagine the solar system turning, with Atlast tracing an invisible arc behind the glare. Control rooms dim their lights, waiting for the first faint dots that will confirm Atlast has reappeared where the math expects. During that waiting period, no alarms ring, and no headlines appear about Atlast. There is only the quiet confidence that gravity will guide Atlast along the curve that was calculated months before. In that calm interval, the story of Atlast narrows to pure prediction, to numbers written in advance. The next step in our journey begins when new observations finally pierce the sunlight and show where Atlast has actually returned. When the first fresh coordinates finally arrived, astronomers leaned in expecting a small comfort. The new data point for ThreeI Atlast appeared on the screen, and Atlast was not where the models had placed that returning arc. At first glance, the difference looked like a simple offset that rounding errors might explain. Then another observation of Atlast came in, and that point also landed well outside the expected zone. Predictions had drawn an uncertainty ellipse, a soft region of sky where Atlast should reasonably appear. Now the actual track of Atlast was sliding along the edge, and then spilling beyond that boundary by distances measured in millions of kilometres. Orbit calculators were updated and rerun each new fit, trying to bring Atlast back into agreement with gravity alone. With every revision, the measured position of Atlast insisted on staying just out of reach of the clean curve. Deviations of a few hundred kilometres are common in early tracking, but this behaviour of Atlast was different in scale. The pattern of shifts suggested that Atlast was experiencing a sustained push, not a random scatter of small errors. For a while, the conversation stayed very technical, filled with terms for non-gravitational forces and model residuals around Atlast. Yet underneath those neutral words, a softer question formed about what could move Atlast so far from expectation, without tearing Atlast apart. You can imagine those growing residuals as a quiet widening of the gap between promise and reality. Somewhere in that gap, Atlast was beginning to be discussed with vocabulary usually reserved for controlled spacecraft. As you drift, the numbers settle into a simple feeling that the path of Atlast has stepped outside the neat lines. From here, the story will turn toward how that step led to whispers about a possible maneuver and the deeper implications for Atlast. Astronomers first reached for the simplest explanation, the one they know best for a wandering body like ThreeI Atlast. Maybe Atlast was just shedding gas and dust in uneven bursts, small jets that could push Atlast gently off the predicted path. Non-gravitational acceleration from outgassing has been seen before, and equations exist to fold those effects into an orbit. For a while, new models tried to wrap around Atlast in this way, tilting force vectors to match what Atlast was actually doing in the sky. Yet as more data arrived, the direction of the required push began to look strange for a natural comet. The inferred thrust for ThreeI Atlast did not always line up with the warmest faces where sunlight should be lifting material from Atlast. In internal notes, some teams started using a different kind of language for the behavior of Atlast. Instead of describing another adjustment to a comet model, a few documents spoke of a second course correction, quietly labeling the pattern as CCM2 for Atlast. That word maneuver usually belongs to spacecraft that know when and how to fire their engines. Hearing it echoed around the data of ThreeI Atlast brought a subtle change in mood, even when everyone insisted that Atlas might still be natural. You can imagine those scientists sitting with the residuals watching the curve of Atlas bend as if a hand had brushed the track. Nothing in the sky shouted no flare marked a burn, but the path of Atlas behaved as though a decision had been made somewhere along that arc. As you breathe, the technical debate softens into a single feeling that the explanations for Atlast are quietly shifting from passive drift toward guided motion. In the next turn of this story, we will follow where that guided motion seems to be leading Atlast deeper toward the broad gravitational domain of Jupiter. When the revised orbit finally settled, the new curve pointed ThreeI Atlast toward a different kind of target. The line no longer described a simple swing around the Sun. The path of Atlast now arced inward toward Jupiter's vast domain. In quiet plots on specialist screens, the trajectory of Atlas threaded straight into the broad hill sphere of the giant planet. That region, where Jupiter's gravity gently dominates, became the stage on which Atlas seemed determined to pass. Statistically, many random paths could skim past Jupiter, but the refined fit for Atlas did more than skim. The projected track of Atlas sliced deeply into the zone where small changes in speed could completely reshape the future of Atlas. To some eyes, this was still just celestial mechanics, a coincidence carved from chance and gravity around Atlast. To others, the alignment of Atlast with such a powerful gravitational tool looked uncomfortably like a deliberate rendezvous. Maps began to show concentric shells around Jupiter, with the thin line of Atlast cutting through them like a carefully drawn arrow. Within those diagrams, Atlast occupied a role less like debris and more like a visitor approaching a meaningful intersection. As you rest, you can imagine that arrow as a soft thread guiding Atlast toward a crossroads in the dark. There is no need to decide tonight whether Atlast is choosing that crossroads or merely falling into it. In the next stretch of our journey, we will drift away from the geometry itself and toward the quieter human timelines that prepared to watch Atlast move through that immense gravitational doorway. Months before the public ever saw the name internal planning papers in Europe, were already quietly making room for ThreeI Atlast. In March 2025, a draft document from the European Space Agency described upcoming interstellar candidates with high predicted anomaly, a calm phrase that now seems to lean in the direction of Atlast. On the surface, such language could apply to a whole catalogue of future visitors, not just Atlast. Yet the timing of that document landing 4 months before the official announcement places a faint circle around Atlast in hindsight. The paper did not shout, and it never printed the full name ThreeI Atlast on its front page. Instead, it listed observing priorities and tracking strategies for objects that would deviate more than usual from standard models, a category into which Atlast would later fit perfectly. You can imagine a meeting room where this was presented, slides moving past with abstract plots and acronyms, never once lingering on the word Atlast. In that room, Atlast was still only a possibility shaped by statistics and simulations, a future line on a chart. The anomaly here is subtle, not a smoking gun, but a pattern in timing around Atlast. Preparations for high anomaly interstellar candidates were being funded and scheduled before any press release mentioned ThreeI Atlast to the world. As you breathe, this feels less like a conspiracy and more like a quiet foreshadowing written into policy. The story of Atlast is already present in those phrases, and in the next soft step we will follow how budgets and observing proposals began to crystallize that anticipation into concrete time on telescopes. Money rarely moves without a reason, and in astronomy the flow of money can be as telling as the flow of light from a visitor like ThreeI Atlast. In the months leading up to the public naming of Atlast research groups, quietly submitted proposals that placed Atlast-shaped questions at the centre of their plans. Requests arrived for expanded observing time on large telescopes, for upgraded tracking software, for additional staff to watch interstellar trajectories like the one Atlast would soon follow. Normally those proposals would sit in long queues reviewed slowly with many projects competing, yet the applications aligned with the future window of Atlast moved more quickly than usual. University teams wrote of enhanced monitoring of high anomaly interstellar approaches, a phrase that now seems almost tailored to Atlast. Funding agencies responded with approvals that came back in weeks, instead of months, as if the system itself wanted to be ready when Atlast appeared. Schedules at major observatories began to show reserved blocks of time labelled for generic interstellar targets. Behind those neutral words, the timing of those blocks matched the expected brightness and geometry of a path very much like the path of Atlast. From the outside, these decisions could be dismissed as simple caution, as a natural evolution after earlier surprises that did not carry the name Atlast. From the inside, the clustering of attention created a gentle sense that a specific guest at last was already anticipated before being formally introduced. You can think of those budget lines and telescope slots as invisible rails being laid in advance, so that the gaze of the world could easily lock onto Atlast when the moment arrived. There is no accusation in this, only a recognition that many people chose to be fully awake to the future motion of Atlast. As you rest, that advanced preparation becomes a soft backdrop, a sign that curiosity and caution were already aligned. In the next part of our quiet journey, we will look up from these civilian observatories and follow how more secretive infrared sentinels also shifted their attention toward the kind of cold, faint traveller that Atlast would become. Long before most people ever heard the name ThreeI, Atlast may have brushed across the field of view of instruments that never published sky maps. In late-night logs from defense networks, infrared sentinels designed to watch for missiles began turning their gaze a little farther out toward the kind of cold, distant glow that would later describe Atlast. These satellites are tuned to heat, to brief flashes that cross the horizon, not to slow deep space wanderers like Atlast. When tasking orders quietly redirected some of those detectors away from Earth and toward the outer dark, the change drew a thin retrospective circle around Atlast. On paper, the shift could be explained as routine calibration or broader surveillance with no explicit mention of Atlast. Yet the timing of those rotations lining up with the inbound window for an interstellar candidate feels in hindsight as though the sky was being prepared to notice Atlast before any public announcement. You can imagine a control room where operators watch faint traces roll across infrared screens, never saying the name ThreeI Atlast aloud. Somewhere in that river of data, a tiny moving point might have matched the future path of Atlast logged, archived and classified. For you resting here, the detail is less about secrecy and more about how many different kinds of eyes were ready for Atlast. Civilian telescopes, agency plans, university budgets and quiet military sensors all seem to have been turning in roughly the same direction toward the possibility of a visitor like Atlast. That convergence does not answer who saw what or when they named Atlast in their own minds. It simply sets the stage for the next part of our story, where the geometry around Jupiter becomes the shared focus of everyone following Atlast through the dark. Around every massive world there is an invisible bubble where its gravity quietly wins. Astronomers call that bubble the Hill Sphere, and in the story of ThreeI Atlast, this bubble around Jupiter has become an important stage for Atlast. Inside a Hill Sphere, smaller objects feel the pull of the planet more strongly than the distant tug of the Sun. Anything that wanders deep enough into Jupiter's Hill Sphere can be slowed, redirected or briefly captured, including a passing visitor like Atlast. You can imagine this region as a soft basin carved into space, a gentle hollow where paths bend inward. As Atlast approaches that hollow, the straightness of the journey for Atlast begins to soften into curves shaped by Jupiter's mass. The numbers that describe this sphere are large, measured in tens of millions of kilometers. From the point of view of Atlast though, the boundary is not a wall but a gradual change in how gravity speaks to Atlast. Far outside, the sun has most of the conversation. Closer in, the voice of Jupiter grows louder, and Atlast moves through a space where small changes in speed could mean very different futures for Atlast. For you lying still, the idea of a hill sphere can be as simple as a safe round valley in the dark. Within that valley, Atlast is not falling in a panic, only drifting through a region where choices, if they exist, would matter more for Atlast. In the next part of our journey, we will quietly explore the main possibilities that astronomers imagine for Atlast in this valley, 3 broad scenarios that unfold from the same gentle mathematics around Jupiter. From the vantage of Jupiter's hill sphere, astronomers tend to imagine 3 broad futures unfolding for ThreeI Atlast. Each scenario uses the same gravity well, but each assigns a slightly different role to Atlast in the quiet story of our system. In the first picture, Atlast arrives with just the right speed and angle to be slowed. For a while, ThreeI Atlast loops as a temporary moon drifting in a high, slow orbit that watches the solar system turn below. In the second picture, Atlast dives through the valley and escapes again using Jupiter as a cosmic slingshot. In that version, ThreeI Atlast steals a little energy from the giant and leaves on a new hyperbolic path carried outward into deeper interstellar night. The third picture is more delicate and more speculative, imagining Atlast using the complexity of the region to hide tiny changes in motion. Inside the tangled gradients of Jupiter's gravity, even a small well-timed push could send ThreeI Atlast out along a radically different course. For ordinary comets, these windows are rare opportunities. For a possibly guided visitor, they could feel like tools laid out on a table for Atlast. Lying here, you do not have to choose which future belongs to Atlast. You only watch the board being set. In the next gentle step of our story, we will turn from these diagrams to a softer question, wondering what it would mean if someone or something had chosen this meeting place for Atlast on purpose. When astronomers look at that deep path into Jupiter's influence, a quiet question appears. If someone were choosing a place for a careful meeting, ThreeI Atlast seems to be heading toward exactly such a place. From there, Atlast would have a sweeping view of the inner worlds watching orbits unwind like slow clock hands. At that crossroads, Atlast could in principle adjust speed and direction with far greater leverage than almost anywhere else. Field of view gravitational tools and long slow arcs all come together around Jupiter for Atlast. In game theory and spaceflight alike, a point like that is where planners would naturally linger, and Atlast now passes near it. Maybe the path of Atlast is pure coincidence carved only by old starlight and chance. Maybe the same graceful mathematics that guides everything else simply happened to draw Atlast through this powerful valley. Or perhaps the orbit of ThreeI Atlast reflects choices layered on top of gravity, tiny decisions folded into each bend. If that were ever true, then Atlast would not just be falling, Atlast would be arriving. Lying here, you do not need to decide which story belongs to Atlast tonight. You can simply feel the scale of the possibility the way Atlast turns a mathematical diagram into a soft, lingering what-if. In the next part of our journey, we will drift closer to the body of Atlast. We will listen to the light and the heat to see whether the physical traces of Atlast match a simple comet or hint at something more deliberate. Picture the space around Jupiter as a slow-flowing ocean dense with invisible currents. Somewhere within that ocean, ThreeI Atlast drifts along a line that curves almost imperceptibly from moment to moment. The pull of the Sun and the pull of Jupiter overlap there, and Atlast moves through the quiet interference of those two vast voices. From one heartbeat to the next, the change in direction for Atlast is tiny, yet over millions of kilometers, the path bends like a long, soft ribbon. You can imagine riding alongside Atlast, feeling no wind, no weight, only the gradual turning of the starfields. In that shared stillness, Atlast is not rushing toward a verdict, only sliding through the layered gradients of gravity. Every so often, computers on distant worlds recalculate where Atlast is and where Atlast might go next. Here, in contrast, your only task is to breathe and let those calculations fade into background hum. The dense field that shapes Atlast can become in your mind a gentle hollow that cradles you as well. From that hollow, we will soon follow the light reflected from Atlast and the heat or lack of heat that tells us what kind of engine, if any, could be at work inside Atlast. When higher resolution images were finally stacked and cleaned, something subtle appeared in the way ThreeI Atlast reflected sunlight. The brightest point in the glow around Atlast did not quite sit at the geometric centre of the visible shape. In a simple ball of ice and dust, the peak of brightness should line up neatly with the middle, but for Atlast it seemed to drift to one side. Frame after frame, the luminous heart of Atlast shifted slightly, as if the core of Atlast were off balance or stretched. Some reconstructions hinted at a long, uneven form, perhaps several lobes joined together rather than a single compact nucleus for Atlast. Other teams saw patchy regions, bright here, darker there, as though different facets of Atlast were flashing past with each slow turn. The data did not allow a crisp portrait, only a suggestion that Atlast is more complex than a simple snowball. You can imagine these images as smudged charcoal sketches of Atlast never quite resolving, but always hinting at hidden structure. In that uncertainty, Atlast becomes easier to picture as a slow tumbling silhouette, textured and mysterious rather than smooth. From this hazy outline we move next to the warmth, or the surprising cold that Atlast radiates, and to what that says about the forces shaping the path of Atlast. Infrared telescopes began to weigh in, measuring not the light that Atlast reflected, but the faint warmth ThreeI Atlast gave off into space. Those readings came back quieter than expected, as if Atlast were wearing a cloak of deep cold. For a comet that is strongly altering its path, outgassing should release energy venting gas and dust and heat. In such a case, Atlast ought to glow more brightly in thermal wavelengths, leaving a warm fingerprint that matches the force nudging Atlast aside. Instead, the curves from infrared data stayed low and flat, tracing a temperature profile for Atlast that looked almost shy. To move the trajectory of ThreeI Atlast by the amounts observed, natural jets would usually need to be loud in heat, but Atlast whispered, or seemed not to speak at all. This mismatch between motion and warmth turned into one of the strangest puzzles around Atlast. You can feel it as a quiet dissonance, a sense that the visible bend in the path of Atlast is not fully explained by the gentle thermal glow we see from Atlast. From that dissonance, imaginations began to reach toward other kinds of engines and forces, leading us softly into theories where Atlast might be driven by something cooler and more concealed. Among the quieter explanations, some researchers began to discuss engines that hardly show themselves at all. They looked at the path of ThreeI Atlast and wondered whether Atlast might be using a kind of electric drive. Ion propulsion does not roar like a rocket. Such a system releases a thin stream of charged particles. From far away, a craft using that kind of thrust can change course, the way Atlast has changed, while leaving almost no visible flame wrapped around Atlast. In that picture, the cold skin of ThreeI Atlast would make more sense. An efficient electric engine could whisper behind Atlast for months, slowly bending the route of Atlast without painting the infrared sky with heat. No one can point to a direct signature that proves this for Atlast. The idea remains a hypothesis, a gentle thought experiment wrapped around the changing arc of Atlast. As you breathe, the notion of a smokeless, nearly invisible engine becomes just one more possible story. From here, we will drift back out to the larger scale toward the human response to a visitor like Atlast, and to the uncomfortable question of how anyone can defend a world against something that may decide where to go next. Planetary defense is built on a simple comfort that orbits behave like promises. Models map where rocks will pass for decades, and those maps now include ThreeI Atlast. Computers take present positions and velocities, and extend clean curves, assuming Atlast and other bodies will only feel gravity and a few well-known natural pushes. That assumption lets agencies decide which objects can safely be ignored and which might someday intersect Earth, and Atlast is folded calmly into those ranked lists. The whole structure depends on one quiet rule that no object like Atlast has reasons or tools to change course on purpose. When anomalies grow, the system first tries to absorb them as measurement noise, gently tugging predictions of Atlast back toward the expected line. Only when the deviations persist do deeper protocols wake, asking whether ThreeI Atlast could be experiencing forces that standard models did not include. In that moment, the comfort that once surrounded Atlast thins not into panic, but into watchfulness. You can sense a shift from treating Atlast as a passive passenger of gravity, to wondering whether someone somewhere aboard Atlast metaphorically or literally might choose a different road. From this foundation, the next layer of our story will rest as we lean into the idea of steering authority and imagine what a third maneuver CCM-3 would mean for the future path of Atlast. Engineers sometimes talk about steering authority, the simple question of who or what decides where a vehicle will go. Applied to space steering authority asks whether ThreeI Atlast is only being steered by gravity, or whether something aboard Atlast can choose a direction. In a purely natural scenario, all the control lies with physics, An Atlast is just a stone carried along fixed fields. In a more provocative scenario, some fraction of the path of ThreeI Atlast reflects guidance, tiny thrusts that bend the track of Atlast on command. The earlier discussion of CCM2 treated one segment of the curve for Atlast as resembling a gentle course correction. Following that logic, a potential CCM3 would be another quiet turner moment, when Atlast might again shift from the line predictions drew for Atlast. From the point of view of planetary defence, the fear is not that ThreeI Atlast is currently aimed at Earth, but that steering authority could someday point Atlast somewhere new. As long as every observed bend in the path of Atlast can be explained by known forces, the system can breathe, and you can breathe with that reassurance. Once the numbers begin to suggest otherwise, teams start running quiet thought experiments, asking when and where a CCM3 by Atlast would be hardest to see. The dense gravity around Jupiter is one such place, a natural curtain where ThreeI Atlast could hide a small change in velocity. As you lie here, these possibilities become soft background stories, not alarms, while Atlast continues along a path that is still being measured, still being argued over, and still leaving room for questions. When analysts change their framing, the same data begins to feel different in their hands. A path that once belonged to a harmless traveller becomes in their models the track of ThreeI Atlast as a potential opponent. Rocks do not plan, so traditional tools treat them as background. But ThreeI Atlast invites a different stance. In that stance, every delay in reporting, every gap in coverage becomes a window where Atlast could in theory do something unexpected. Campaign schedules start to look like patrol routes, a mesh of observations designed to leave as few blind spots around Atlast as possible. Simulations no longer ask only where Atlast will be, but where Atlast would choose to be if a small reserve of control were available. From a distance, this is still just numbers and plots, gentle lines tracing the progress of Atlast. Up close, the mindset is closer to a chess player watching a rival piece, waiting to see whether ThreeI Atlast advances, pauses, or pivots. For you lying in the dark, that shift of perspective is simply another layer in the story. The same curve in space can be a stone's fall or a deliberate path for Atlast, and tonight you are free to hold both meanings lightly. In the next softer chapter, the focus returns to your side of the sky, to how people design their defences and their sleep, when a visitor like Atlast might someday make a choice. For the people who designed it, Campaign 8 is more than a schedule. Those 2 months form a narrow window through which the true nature of ThreeI Atlast might briefly come into focus. Every night inside that window, telescopes turn and record new points, each one a small vote on what Atlast really is. If the curve of Atlast can be explained by gravity and gentle outgassing alone, confidence quietly grows. If the pattern of Atlast keeps slipping toward course corrections, another story gathers weight. For you, these 60 days are simply a stretch of time in which others stay awake with Atlast while you're allowed to sleep. In quiet meeting rooms, teams run simulations the way others play slow games. Each scenario is a different future, all starting from the same present track of ThreeI Atlast. In one, Atlast swings past Jupiter and drifts outward forever, a brief curiosity that leaves the inner worlds untouched. In another, ThreeI Atlast uses the giant's pull as a slingshot, vanishing into deeper night on a new, sharper trajectory. The most closely watched case lets Atlast bend inward, instead turning toward Mars or Earth. Even then, ThreeI Atlast remains only a possibility on a screen, not a verdict.